Today I'm going to talk about the Dewalt Flexvolt 60 volt 9 amp hour battery pack. I'm going to do a partial teardown, not a complete teardown, but just a partial teardown to show you in details how it works, how Dewalt can turn a 20 volt battery pack into a 60 volt battery pack in an instant, just like that. So let's get started. So here's the inside of the battery pack. There are 4 screws on each side. So I remove the 8 screws to get these 2 covers out. The top cover, I just have to pry it off. There's no screw for the top cover. Right, so let's take a look at the terminals on the batteries. We got a positive and a negative terminal on the batteries. So we got around 18 volts right now. Okay, and if I put my 20 volt tool, the older 20 volts tool, to the battery, it will contact to the 2 terminals here, right? And that will run my tool at 20 volts. Okay, the difference between a 20 volt tool and a 60 volt tool, 2 things. Okay, number 1 is the extra pins on the 60 volt tool. 2 extra pins. Okay, this one's got 4 pins and that one got 6 pins. Okay, and if you take a look at the board, these 2 pins on the top here, okay, corresponds to pins C1 and C3. Okay, these 2 pins on the top. There are 2 pins on the bottom also. Only the 2 pins on the top is connected to the circuit board. Okay, so you take a look at the 60 volt tool. There's 2 pins on the bottoms here, and they are somehow connected. So if I put it on continuity and measure it, you will see that these 2 pins here, C1 and C3, is connected. Okay, among the 6 pins in this 60 volt tool, no other pins are connected except C1 and C3. You can see there, and that corresponds to these 2 pins on the battery. This one here and this one here, that goes to the 2 cable, then connected to the circuit board. So believe that is the switch that talks to the circuit board, and it will tell the circuit board, hey, I'm here, I'm 60 volts. Okay, I'm not 20 volts. So we'll switch on 60 volts instead of 20 volts, because the 2 terminals here are still the 2 main terminals for the 60 volts tool. But when you insert this in here, it's not 20 volts anymore. It will become 60 volts. Right now, if nothing is inserted, okay, it's 20 volts. And also there's another switch here. This switch, I believe there are 2 switches. One on the top that talks to this circuit board. This switch on the bottom here is also another switch. And if you insert the 20 volts tool in this battery, so these 2 pieces of plastic here, you will see it's right here, and it comes in and out. Okay, and then if you insert a 20 volts tool on this, it does not have anything to do with that switch. Okay, this switch is untouched. Okay, for the 20 volts tool. But if you insert a 60 volts tool in this battery, on a 60 volts tool there are two plastic knobs on the bottom, and when you push it in, it will push the switch in. See there? It goes into that slot and push the switch in and makes it run at 60 volts instead of 20 volts. So there are two things that happen simultaneously when you insert a 60 volts tool in this battery. Okay, number one is the two pins on the tool, okay, in which there's one extra pin that the 20 volts tool doesn't have. It's this pin in the middle here, and this somehow is connected to the pin right next to it, okay, the copper collar pin right next to it. This pin here has a different color, look like stainless steel color. But these two pins here, C1 and C3, looks like copper color. The pin on the top here is stainless steel. But anyway, so the two C1 and C3 pins will connect to these two pins on the top here of the battery and talks to the board and tells the board that it's a 60 volt tool. At the same time, it pushes this switch in. That's the two things that happen when you insert a 60 volt tool in this 60 volt battery. I did a continuity test for pin C1 and C3. See there, it's connected. Right? It's sorted out. That means when this tool, the 60 volts tool, is inserted in the battery, this two pin here that connects to this board is going to be sorted out. Okay, now I'm going to sort out the battery with a paper clip. Okay, I'm going to sort these two pins out. Okay, now if I measure the voltage on the two terminals, okay, it's still 18 volts. So now I'm going to try to simulate the insertion of a 60 volts tool without the tool by pushing this switch here on the bottom. So I already connected the two pins together, sorting it out. The two pins go to the circuit board. Okay, now I'm going to push this in, the switch on the bottom. So here we go. We got 60 volts out of the two main terminal. So it's no longer 20 volts. Of course, you see 53.9 because the battery is low, right? But when it's fully charged, it should be around 60 volts. So there you have it. How to turn 20 volts into 60 volts. Now let's take a look at the switch on the bottom here, the one that pushes in and out. Now we would just push just a little bit in, about 2 millimeters in. Okay, we'll completely turn off the terminal, right? If we push all the way in, I'll get 60 volts. Okay, and that's what happens with this cover. This is for safety when transporting the battery. So let me demonstrate here. Let me put the cover back in. Okay, and if you take a look at this cover, there are two pieces of plastic on the bottom here. When you push it in, it will go to this switch, and it will just push in just a little bit. Okay, see there? Up to this point, it's just touching the switch, and it only has about 2 or 3 millimeters to go. So when you push it all the way in, okay, so it only travels about 2 or 3 millimeters. That's it. and that's enough to turn off the terminal. So now the terminal coming out of here is 0 volts, and that makes it safe for transport. So next, let's take a look on how this battery is being put together. I've got the top here, this is the front, this is the left side, and that's the right side. Okay, I got my diagram here that shows the left side of the battery. So this surface here is on this side, the left side of the battery. I've got 15 cells here. I've numbered them from left to right, 1 to 5, 6 to 10, and 11 to 15. The red connections are the series connection between the batteries. So for example, cell number 1 positive terminal is connected to negative terminal of cell number 11, which is this cell here. The cell here is being connected, the positive of this cell is being connected to the negative of this cell. So number 1 positive, number 11 negative. And same for the other connections. This one here is this. Okay. This here is this. Right. If you look at the Dewalt advertisement, you see that they advertise the batteries being connected in series as like this, like that, and then up, and then like that. But in reality, it's not, absolutely not like that at all. It's very strange configurations, and in this kind of configuration we got 3 packs of 18 volts batteries. So pack number 1 is here. You see the purple pack, they all connected in series to produce 18 volts. Pack number 2 is in the middle. You see the orange border here, and pack number 3 is the green border pack. Okay, in which the positive terminal, for example, the green pack, the positive terminal is positive of cell number 10, and it's being connected to the BMS, the circuit board. Okay, right here. So cells number 10 is here. It's being connected to the BMS right there, to the board right here, which is this. So on the BMS circuit board, it's got 6 connections to the battery. Okay, so 3 on this side, 3 on this side, in which I've got, let me zoom out a little bit. Okay, you got positive terminal of cell number 2 here, positive terminal of number 4 here, and positive terminal of number 10, cell number 10. Okay, on this side is all negative, which is this side. It's all negative. So negative terminal of cell number 1, which is this cell here. This is the same cell. Okay, this is the other side of the battery pack. Yeah, this is the other side of the battery pack. That's the right side, which is this. That's the front, that's the left. Okay, so cell number 1 is positive on this side, negative on this side. So that is cell number 1 right here. Positive here, negative here. Okay, so same on the other side. This is the group 1, 18 volts, group 2, 18 volts, and group 3. Okay, so the BMS on this side is got 3 connections: negative terminal of cell number 1, negative terminal of cell number 3, and negative terminal of cell number 5. The front of the battery has got 5 pins. Okay, these are the pins on the front. 1, 2, 3, 4, 5, which has 3 main terminals, a positive terminal right here and negative terminal on this side. So that's what we got here. So normally when this switch here, when this switch is off, that means you only use a 20 volt tool, for example. Right, so when you insert a 20 volt tool in, it does not push this switch in, so this switch will be off. So normally this battery is a 20 volt battery. All of these terminals, all of these negative terminals are being connected together. Same for the positive terminal on this side. Okay, so all of these are connected together. All of these are connected together. So this is the negative terminal of the purple pack. This is the positive terminal of the purple pack. Okay, same here. This is the negative terminal of the orange pack, and that's a negative terminal of the orange pack. Same for the green pack. So normally all of these terminals are being connected together. These are being connected together in parallel, and that's how it can produce 18 volts. Now I can demonstrate that using the continuity test from my multimeter. That's connected, and this is connected, and of course these two sides are not connected together. Okay, you see the number jumps because there's a voltage difference between this and that, but they are not being connected together. Same here on this side. So if I flip this over, measure on this side, so that's being connected together, that's being connected together, and that's being connected together. So all of these, all 3 connections here, they're all connected together. Same on the other side. And there are also 3 connections between these 2 terminals: the positive terminal, the negative terminal, and the terminal here on the BMS. So connection between cell number 10 positive, this one here, which goes up here to here, is being connected to the positive terminal permanently. That's a permanent connection regardless of whether this switch is on or off. Same here on this side. This terminal here, which is negative of cell number 1 right here, which is this one here, is being connected to the negative terminal permanently regardless of the switch is being turned on or off. It doesn't matter. That's permanent connection. There's also one temporary connection between cell number 5 negative, which is this right here, to the negative terminal. That is a temporary connection. What that means is when you push this switch, actually let me show you right now. Okay, so when I push this switch on, that means when a 60 volt tool is being used, this connection is being cut. It's disconnected. Normally it's being connected. So how can the volt change from a 20 volt battery pack into a 60 volt battery pack in just an instant? Boom, just like that, and it turns into a 60 volt battery. The secret here lies in this switch, and there's a lot of things that happens when you turn on this switch, when you push the switch in. The very first thing that happens when you turn on this switch, when you push it in, is it disconnects all of the parallel connection here and here. So let me demonstrate. I'm going to push this in. See that it disconnect these two connections, and not just these two. This also and this also. Same here on this side. Let me demonstrate on this side all of the parallel connections. Let me push it in. Disconnected. The second thing that happens at the same time when you push on this switch is it's gonna connect the positive terminal of cell number 2. Okay, it's also on the BMS, which is this here. This one right here. It connects positive of number 2 to negative of number 3. So this is going to be connected when you push this switch on. Let me demonstrate. See that? So back to the diagram. When positive terminal of cell number 2 is being connected to negative terminal of cell number 3, that means these two pack, the orange pack and the purple pack, they are connected together in series. So 18 volts individually now becomes 36 volts, in which the negative terminal of the new battery now, new 60 volt battery now is here, negative 1, and the positive terminal is positive 4, which is this one. Negative terminal here, positive terminal here of a 36 volt pack. Let me demonstrate on the battery pack. I'm connecting these two terminals here, which is negative 1 right here and positive 4 right here. Okay, we got 18 volts. That's because between here and here, which is the purple pack, it's 18 volts. But because this and this is being connected together in parallel, so it will be the same as between here and here. So it's still 18 volts. Now if I turn on this switch, instantly become 36 volts. So now the purple and the orange pack, these two packs here, are being connected and becomes a 36 volt battery pack. To make it more simple to understand, I have another drawing here. So now we have a new battery pack that is 36 volts, right, when the switch is pushed in. And this pack here is still 18 volts, right? There's nothing changed on this pack yet. This here between -5 and +10 is still 18 volts, right? Which is the green pack is still 18 volts. And when that switch is pushed on, right, at the same time, it's connecting terminal +4 to -5 to make everything to make these two packs become a 54 volt battery pack, in which the negative terminal is here and the positive terminal is here. Okay, but the problem when you connect these together, right, is now you're sorting the 36 volt battery out. You're making this terminal here, see, you connect this to here, and because these two terminals are being connected together, now you're sorting this and this together. Okay, so the volts fix that problem by disconnecting this connection at the same time these connections is being made. So you can, as I said earlier, these are connected in parallel, same here on this side. So when the switch is on, all of the parallel connections are disconnected. The red connections here are the parallel connections. All of the red connections are being disconnected. at the same time this connection is being made. So as you can see, there is a lot going on when you flip the switch on. Okay. This connection is being made. This connection, this one and this one, they are being disconnected. Where when at the same time the green connections stay the same. That means that now the new battery pack is 54 volts, in which the negative terminal is right here, the positive terminal is right here, but these terminals are permanently connected to the main terminal of the battery on the top here, which is this and this. Positive here, negative here. Positive here connected to cell number 10, positive, which is here, right here. This is the permanent connection, and this is also the permanent connection of the negative terminal of a new 54 volt battery pack. And let me demonstrate on the battery itself, actual demonstration. Okay, I'm gonna push the switch on. You can see it's instantly become a 54 volt battery pack. So there is a lot happening at the same time when you push this on. Now let's take a sneak peek of what's inside this battery pack, the cells that are being used in this pack. Now I don't want to completely remove and tear down this whole battery pack, because I still plan to use this pack for my other projects, and those are gonna come next. I'm just gonna take a sneak peek here and looking at the size of the cells. It's not a regular 18650 cells. It's fatter. The diameter of the cell is bigger, and it's about 21 millimeter, whereas this is a regular 18650 cell. It has 18 millimeter diameter. Okay, just measure the plastic here. Just gonna touch on the plastic. 64, 60, about 64. Okay, anyway, 18650. This cell here is about 70 millimeter, right there. So this cell is actually a 21700 cells instead of 18650. And I think the reason why, I could be wrong, but I think the reason why Dewalt use a bigger cell is, number one, it has more capacity, of course, but if you look at this cell here, this is the HG2 cells. Okay, this is also a high discharge cell, 20 amp discharge, and it's a 3 amp hour cell. Okay, this is a 2 amp hour cell. This is Sanyo cell. It's exactly the same size. So why doesn't Dewalt use this cell instead? Because each cell here is also 3 amp hour, but the physical size is bigger. Why do they make it bigger? And I think the reason why they use a bigger cell, despite the fact that it will make the battery bigger, is because of the discharge rate. I could be wrong again, but that's what I think. 20 amp discharge rate. These cells here, they are about 30 to 35 amp discharge rate. So it's got a lot more discharge rate, because there's a good reason for that. Because it has to run these Hercules These things are huge and a lot more powerful than the older 20-volt tool. Not only this, but it also runs miter saws, which consume a large amount of power. So that's the reason why I think Dewalt use a bigger 21700 sails instead of regular 18650. As far as the brand go, and again, I'm not at the point where I want to completely tear down this pack yet, but I will in the future. Comparing the color, I can guess that this sail is made by Sanyo. It's all color coded. This sail here is made by LG, and this sail is used in the Milwaukee 9 Ah battery pack, and it's a bit smaller and lighter too, and it has the same capacity as these bigger sails here, but the discharge rate is a bit less. And also I got these, quite a few of these, for a pretty good deal, and I plan to use this for another project of mine, and I will show you the projects on these sails in my next videos. Right, so there you have it, a partial teardown of this battery, and just want to show you how this works. This is a marvel of engineering, really. You know, just want to flip a switch, and you can switch from one voltage to another, and that makes it very useful, very versatile. And you know, I hope in the future there's going to be more batteries like this. This is very, very useful. I plan to use this battery for my next project, so stay tuned and I'll see you next time.